Section 3.8 is on solving systems of equation using inverse matrices. The identity matrix is a square matrix that when multiplied by another matrix equals the matrix. It's a lot like the number 1. It's like multiplying a matrix. What can you multiply a matrix by and get the same matrix out? It's called the identity matrix, and it's indicated by an uppercase printed I. A 2 by 2 identity matrix looks like this: 1, 0, 0, 1. And a 3 by 3 identity matrix looks like 1, 0, 0, 1, 0, 1, 0, 0, 0, 1. And you can notice that the 1s are in a diagonal. And you can probably guess what a 4 by 4 identity matrix is going to look like. So why does this matter? If a matrix is multiplied by its inverse, it equals the identity matrix. It equals 1. So if I have matrix A, and it's multiplied by its inverse. Now remember, -1 isn't always like to the -1 power. It can also mean in algebra, it can mean to the inverse. So a matrix times its inverse equals the identity matrix. It's like you're saying A times 1 over A equals 1. It's kind of like multiplying by the reciprocal. And the inverse of matrix A, which would be matrix ABCD, is defined to be this. So it looks like A to the -1, but we say the inverse of A is 1 over A times D minus B times C, which you should notice as 1 over the determinant of a 2 by 2 matrix, times the matrix D, -B, -C, A. Now the nice thing is you don't have to memorize this because we're going to be doing this in the calculator, and your calculator can figure out what the inverse of a matrix is. So why are we going to use this? We're going to use this to solve systems of equations because you can take a system of equation and write it as a matrix equation. So here we have the system x plus 2y equals 9 and 3x minus 6y equals 3. So I can take the left side of the equal sign and put that into square brackets and make that a matrix, and I can take the right side of the equal sign and put that in square brackets and make that a matrix. Or I can pull out the x and the y so that I have the coefficients 1, 2, 3, and -6. You'll see those are the coefficients up here, 1, 2, 3, and -6. And then I have x and y in a matrix by themselves. And then I have the numbers over on the right, 9 and 3, in a matrix by themselves. We call this first 2 by 2 matrix the coefficient matrix because it just pulls the coefficients off of the system of equations. The variable matrix, well, that's kind of obvious. It has the x and the y. Those are our two variables. And then the constant matrix is what those two equations equal, 3 and 9 and 3. We call the coefficient matrix matrix A. We call the variable matrix matrix X. Kind of makes sense since that's one of our common variables. And then we call the constant matrix B. So we have the equation A times X equals B. Now, if you multiply both sides of this equation right here, A times X equals B, by the inverse of A, right there in front of A, and the inverse of A right here in front of B, remember the inverse of A times A is the identity matrix, which is basically just 1. So in a sense, that kind of cancels each other out. Then we're left with X equals the inverse of A times B. So remember, X was our variable matrix. So basically, if I take the inverse of my coefficient matrix and I multiply it by my constant matrix, I'm going to get a variable matrix that's going to have my solution to the system of equations. So let's take a look at how this is going to work. So in your calculator, you can input matrices A, and B, and do this in your using the operations. Let me pull up my calculator and show you how this is going to work. Okay, so here's your calculator, and we haven't done a whole lot with matrices in the calculator yet, but you'll notice over this button right here, it actually says matrix. So to access that, I'm going to do second and bring up the matrix menu, and you'll notice there's 3 submenus here: names, math, and edit. Names is when we want to just call up the name and use it as though it were a variable or a value. Math, these are the different things that we can do to the matrix, and edit is how we're going to create these matrices. So let's arrow over to edit, and I'll go down to matrix A here. Whoops, I'm already in matrix A. Hit enter. Okay, and by default, matrix A This one just happens to be a 1 by 1 matrix. But I'm going to do the example that I showed you in the notes over here. Let me go back here. We're going to do this one here. I'm going to plug this in and show you what it looks like. Okay, so this is a 2 by 2 matrix, so I can do 2, enter, 2, enter, and you can see it's created a 2 by 2 matrix. And this is going to be my coefficient matrix, so I had 1, enter, 2, enter, 3, enter, -6, enter. And there's my coefficient matrix, and I'm calling it A. Okay, let's get out of this. I'll do second quit and go back to my matrix menu. And now I need to create matrix B. So I'll go down to there, and I have edit highlighted, hit enter. Okay, and this needs to be a 2 row and 1 column matrix, so it's going to be a 2 by 1. And that's what it looks like. And this is my constant matrix, which had a 9 in it and a 3 in it. Okay, so that's my matrix B. So let's quit. So let's go back to our notes here. So what I need to do is I need to do the inverse of A times B, and that's going to give me my variable matrix. So let's take a look at that. So to get matrix A up here, I need to go to second and pull up matrix. Here's where I'm going to use names. So I'll hit enter. And I need the inverse of that, and that's this same button here that matrix is above, the x to the -1. That's the inverse of A times, and let's go back to matrix because now I need the name of B. And then I'll put B on my screen. So here I have the inverse of the A matrix times B. And when I hit enter, I get a 2 by 1 matrix with a 5 and a 2 in it. Remember, this is my variable matrix where 5 is the x and 2 is my y. So the solution to this system of equations is x equals 5 and y equals 2. So let's do a couple examples. Okay, so let's solve this system using a matrix equation. First thing I'd like you to do is I want to see the matrices that you write out. So let's create our coefficient matrix with 4, -2, 6, and 9. My variable matrix is an x and a y. And my constant matrix is 22 and -3. Okay, and remember this is A, this is x, and this is B. So in order to find x, I need to do the inverse of A times B. Okay, and I don't need to go through the process of finding the inverse of A like I did back here. There we go. That's how we found the inverse of A right there. I'm going to use my calculator. Whoops. There we go. So let's pull up the calculator again and put these values into matrix A, these values into matrix B, and then do this equation here. Okay, so let's go back to matrix. And I want to edit matrix A. And this one is going to be a 2 by 2, so I'm fine. But the values I need in there are 4, -2, 6, and 9. Okay, now can I go right to matrix B? Yeah, let's go over and edit matrix B. That's my constant matrix, and I still need a 2 by 1, but the numbers in there were 22 and -3. Okay, now let's quit and go back to my main screen. And I need to name matrix A. I need the inverse of it, and I need to multiply it by the name of matrix B. Hit enter. There's my equation. Hit enter again. So my solution is the ordered pair 4, -3. X equals 4 and y equals -3. So my solution is -4 and 3. Okay? Now you may think that's a lot of work for just solving a simple system of equations when I can use elimination or sometimes substitution. Where this is really helpful is when you have a system of 3 equations with 3 different variables. You remember from a couple sections ago how long and tedious those problems were. So let's use a matrix equation to solve this. So let's create our coefficient matrix by just pulling the coefficients off, paying attention to the signs. Okay. My variable matrix, since I have 3 variables, is x, y, and z. And my constant matrix, 60, -12, and -52. So this is my A, this is my X, oops, and this is my B. So my X is going to be equal to the inverse of A times B. And let's go ahead and put those in our calculator. I'm going to clear my key press history here. It's getting a little sloppy. Okay, so go to matrix. I'm going to edit matrix 1. One more over. Go one more over. Okay, there we go. Enter. And I need a 3 by 3 matrix because this is a system of 3 equations. And I just input my coefficients. Oops, that should be -4. Can I go back up there using arrows? There we go. -4. And then 2, 4, 3, and 6, -3, -2. Okay, so there's my coefficient matrix. Let's go and put in our constant matrix, and that's going to be in matrix B. And this one has 3 rows and 1 column. And I had 60, -12, and -52. Okay, and let's quit. And actually, I think I'm going to try a shortcut here since I'm basically going to be putting in what I put in the last 2 times. I think I'm just going to do second and enter, and that'll bring up my last entry. And it should be able to access the new values that I put into the matrix, and hit enter again. And there's my solution. The matrix -8, 4, and -4, which corresponds to the ordered triple, -8, 4, and -4. So in this section we took a look at the use of an inverse matrix and the identity matrix to help us to achieve that inverse matrix, and how to use inverse matrices and matrix equations to solve systems of equations, particularly systems of equations that have 3 variables.